Stereoscopic and comparison microscopy. A stereoscopic microscope also magnifies objects set on a stage, just like in compound microscopy. This is not going to be at nearly the same degree of magnification, and ultimately you're going to be provided a much larger field of view and a larger depth of focus to be able to get some detail on a larger 3D image, but you can see more of it with a stereoscopic microscope. The image is still quite high resolution. As with the compound microscope, you view a virtual image. Let's take a look at a stereoscopic microscope. You can see that it looks pretty similar to a compound microscope, but with some real key differences. Similarities include that you have an eyepiece, you have an objective lens, you have a focusing means, you have a base, you have a stage, you have a diopter, so you can focus these to your own prescription. For those of us who have terrible eyesight and their eyes are pretty different prescriptions, this is a real blessing. It means I can take my glasses off. I can see better through the lenses since I don't have my glasses in front of my eyes, and I can adjust to my prescription, so things are nice and focused anyway. It has a light source, a lot of similarities. Basically, it's the same type of equipment, but with some modifications. The first thing is that there's only one objective lens. Magnification changes, so like you can view anywhere between like 10 to 125x magnification or so, is going to take place with a series of lenses that are internal, and you change the distance between them to change how magnified the image sitting on your stage is. So you don't have those objective lenses to swap out or rotate. It's all just sort of fixed. You're still going to focus like usual, but there's no coarse versus fine focus. It's just a focus. You have two different light sources that can view something on your stage. So you have, say, a shell casing right here on your stage. You can either view it with light that comes up from below or top lighting to come down at the object and then reflect up through the lenses and into your eye. Remember, with a compound microscope, your only option was through the object. So you can think that this might be good for a very different type of materials than a compound microscope. So again, it's similar in function and how it works to a compound microscope, but it has a fixed objective lens and the magnification changes based on the distance between those internal lenses. This creates a right side up image. Ultimately, it's got a couple other lenses on the inside there, and your image is in fact oriented how you interact with it in 3D space. This is really nice. If you think back to that last slide, you have your stage right here. You've got a couple clips to help hold stuff down if you need to. And you'll have your object right here, right? Since it's right side up, it's pretty, and you have a lot of distance between the lens and the stage. You can put largish things down on it. You can go down with your own hands and physically manipulate it, turn it around, shift it left and right. You don't need to worry about using the little knobs to move your slide around in the right direction while taking into account that everything's upside down and backwards. It's a lot more intuitive to interact with. So benefits, again, it is easy to train personnel to use it. It's very, very intuitive. It can magnify pretty well. I mean, it's not as good as a compound microscope, but you can still see a lot of detail. It's very inexpensive. These things are quite a bit less expensive typically than compound microscopes. You can't see quite as much. At least you can't zoom in quite as much. You can't get as much detail out of it necessarily, but that's okay. Sometimes that's the appropriate thing. Sometimes you want a lot of context or a lot of depth or a large field of view so that you can get a sense overall of what you're looking at instead of just focusing in on a tiny little detail. You've got a large working distance. Again, this enables easy manipulation. It's the same size and weight basically as a compound microscope. It just needs to be plugged in to an electric socket to fuel the light, just like a compound microscope. So pretty easy to bring to and house in a command center. Because you have a large depth of focus. So remember, in a compound microscope, the light rays have to are focused in a very narrow window. With stereoscopic microscopy, you have a larger depth of focus. So you can see more detail in focus at different depths than you can in a compound microscope. Different modes of illumination are helpful, so your object does not have to be translucent to make out meaningful details. If you have something that light can't go through, no big deal. Just switch the light, comes down from above. You can see a lot of surface detail this way. And like a compound microscope, it provides images at a high resolution. This is the most used microscope in forensics, especially in the field at the crime scene, by far. Many of you have used a compound microscope in high school or middle school or something in lab. You may or may not have used a stereoscopic microscope before. This will, on a compound microscope, you have to mount everything on a slide, right? So it has to be a very thin kind of a thing to fit on that piece of glass to look at through the lens. Here, you can chuck all kinds of things up onto it as long as it fits between the lens and the stage, and you can put like most of your fist in between that distance when it's at 10x magnification and zoom back. You can see quite a bit. You could put shell casings on it. You can put the handle of a weapon on it. You can put a sweater that has a bunch of blood spatter and hairs on it. You can put an object that you're looking for latent fingerprints on it. All kinds of different objects can fit on that stage and can be viewed. Very, very, very versatile piece of equipment. It's kind of like it has most of the benefits, if not all, of a regular portable magnifying glass, with very few of the drawbacks. It works better. You can see more stuff. You can illuminate it. It just doesn't fit in your pocket. Drawbacks are limited to mostly that you have a very limited magnification. It requires periodic calibration and maintenance. This is an additional cost that you have to spend as a department over something like a magnifying glass that never requires maintenance. This seems like a trivial point. Who cares? Of course, everything needs maintenance. But the more specialized the maintenance, the more expensive this piece of equipment is overall to your department. And the more expensive that is, the harder it is for a department to be able to afford it or justify it. And of course, because those lenses are all on the inside, you can't just swap them out like you can on a compound microscope. If you take that stereoscopic microscope to the command center van, the van hits a big old bump, you knock one of the lenses out of alignment, that microscope is out of commission until you get a guy to come out and service your microscope. Comparison microscopy is really just a modified form of compound microscopy. There's also comparison microscopes that have stereoscopic capabilities as well. What this is really just two microscopes in one, and then you can view two images next to each other. So you have one set of objective lenses here and another here. You have a stage there and a stage there. You have one set of objective lenses, and this one is hooked up to a camera, which you can see a cable coming back here that goes to the computer screen. So this person is looking at them on the computer instead of through the lenses, which is convenient and frankly just really comfortable ergonomically. So what you can do is you have your adjustment knob, and it controls either or both of these stages. So you can move either of them so that on your screen they line up the way you want them to. They're oriented the way you want them to be. So like here you can see whatever this word is at the top, same word here, bottom, bottom, they look to be about the same word. You're going to take a standard reference sample and your suspected evidential item and compare them side to side. You can line up striations. You can confirm manufacturer information. You can look at class or individual characteristics with your standard reference item and your potential evidential item and see them side by side. Having them right here next to each other on a screen or in front of your eyes at the same time, in real time, increases the likelihood that your match is in fact a true match. It reduces some of the subjectivity involved in making these judgments. Though, keep in mind, whenever a human being is making a judgment call, there is always subjectivity involved.